This is MAP4C, day 11, and today the lesson is a review lesson on volume and surface area. Now normally we just sort of smash review lessons in with the other stuff and not spend a full day, but it is I think it's worth it. The 3-minute review is to do some questions from the textbook, so you go ahead and try those, and I'll take at least a couple of them up almost straight off. It's old stuff that should be no trouble, converting between metric and imperial units. Okay, so I'm going to do one of the ones from number 1, and then I'll do number 2 as well, and hopefully you're having no trouble with this. So I'm going to do just by random, I'm going to do B here. A gas tank can hold 80 liters, convert to gallons. So we need the one that goes from liters to gallons. The fact that goes from liters to gallons, liters to gallons, liters to gallons. There's the fact right there. This is also, remember, in the back of your textbook, the very last page, you can find all these facts. So we've got 1 liter is 0.22 gallons. And so then if we've got 80 liters, it's easy to see, multiplied by 80, 0.22 times 80 is, bash that into a calculator, 17.6 gallons. And the other ones are similar. You just got to pick the right fact and multiply. Number 2 is a little bit more difficult because there's more numbers involved. It says in 2005, Canadians consumed on average 94.7 liters of milk per person. Americans consumed on average 21.2 U.S. gallons per person. Each U.S. gallon is equivalent to 3.785 liters. And we are supposed to ask, who drinks more milk, Canadians or Americans? Well, we can see 1 U.S. gallon is 3.785 liters. So, well, which one do we have then? Then 21.2 U.S. gallons is going to be that number times 21.2. And that is about 80.2 liters. And so the Americans drink about 80.2 liters. Canadians drink 94.7 liters. So then you should have a closing sentence. Therefore, Canadians drink more milk. And to justify your answer would be this work right here, wouldn't it be? Okay, on to the lesson. And you see that it's not part of the unit itself. APK stands for Activating Prior Knowledge, and it goes in the preview section of this chapter, the expectations to calculate volume and surface area of 3D objects, and we'll see why we want to do some review soon. Calculate the volume and surface area of each. Well, this shape, triangular base prism. Prism because it's got 2 faces that are opposite and identical. And so yesterday or last day we spent some time working on some formulas, and hopefully you got your formula sheet. If I want to look, where's the formula for a triangular base prism? There's prisms, and prisms are volume is area of the base times the height. And in particular, there's the one for a triangle, but I kind of like using for the volume area of the base times the height, so I'm going to use that one. Area of the base times the height, where the area of the base in this case are the 2 equal and parallel sides, which are triangles. So here, the base is 5 and the height is 5. So I can calculate what the area of one of these bases is. 5 times 5 divided by 2 is 12.5. That's centimeters squared. The height of the object is how far apart the two parallel faces are, and that's, I can tell because of that, that's 5 centimeters as well. The height of the object is 5 centimeters, and hopefully you're not getting that confused with the height of the triangle. Height of the triangle is 5, base is 5, height is 5, but also the height of the prism is also 5. So prism area of the base, 12.5 times the height of the prism, which is 5, and I get that as 62.5 centimeters cubed. Surface area I always find more difficult. I'm going to change colors here for surface area. Why not? Surface area, because really, if I look at my formula sheet, for surface area, we just want to add up the faces and look for shortcuts. And there's some specific ones if you're a formula person, but I mean, really, that's the strategy. Add up the faces and look for shortcuts. So if we think about the faces, I've got two triangles, right? The two faces, I got two triangles. So I'm going to find those. Well, in fact, one of them's 12.5. We found that when we found the volume, right? So I can go, the two triangles is 2 times 12.5. That's 25. And that accounts for the front and the back of that 10 shape. Well, what else have we got? Can we look for a shortcut? Well, notice that the left side, this side here, and the bottom are both 5 by 5, right? You see that? They're both 5 by 5. So I'm going to say the left and the bottom are 2 length times widths, where they're exactly the same rectangle. In fact, they're squares. 5 times 5. And that's 2 times 5 times 5 is 50. What else have I got left? I got the slant side. You see, like the ramp here is 5 centimeters long, but we don't know what this length is here, right? I'm going to call that X. How do we find that? Well, if I look here, this is also X, isn't it? 5 here, 5 here. This is Pythagorean theorem, right? So over here in my rough work, and X is the square root of 50, which is about 7.1. And so then I got the slant side is just a, slant side is just a rectangle, length times width, 7.1 times 5, which is 35.5. And then the surface area is just the total of all these faces, right? This is a bit of work. And that's what is that? That's 75, 110.5 centimeters squared. All right, number 2 over here, cylinder. Cylinder is kind of like a prism, so we could use same formula where the area of the base is a circle, right? The 2 parallel and congruent sides are circles. Or you could just use the formula, get a formula sheet on this test. The radius, so that's the diameter, isn't it? That's the diameter. So the radius is half of that. The height of the cylinder is 8. This is in inches, and everything's in inches, so we don't have to do any conversions or anything like that. 4 squared times the height. That should go into your calculator in one step. Use your pi button. Pi times 4 squared times 8 is about 402 cubic inches, which is a strange measure, but good enough for us. Surface area. And again, this one I'm going to use the formula. We could add up the faces, but the faces for a cylinder are a little bit weird. We know we got the 2 circles there for area of a cylinder, but the curved side, what's called the lateral area, is this little formula. And hopefully you remember using that before. We've got our top and bottom plus 2 pi RH, where these are all the same values still. I suppose you could put them right into your calculator without having to write this down, but I'll write them down anyway so we see what we're putting into our calculator. And then this all goes into your calculator in one step. 2 times pi times 4 squared plus 2 times pi times 4 times 8, and you get about 301.6 square inches. All right, next. And our textbook doesn't have too much of this, but these shapes that come to a point, pyramids, right? This one's a cone, circular pyramid, it's a cone, but there's formulas for it, and we'll just find the surface area and volume here too. Anything that comes to a point, the volume, instead of just area of the base times the height, it's area of the base times the height divided by 3. So area of the base times the height divided by 3, that's the volume of a cone. Area of the base is a circle, you can see it there. The radius is 6, the height is 8, and it's all good. Bash away at our calculator here. Divide by 3 at the end. You just put this into your calculator exactly as it appears, and you get the answer about 301.6 centimeters cubed, because it's volume. All right. Now, what's a little bit strange about cones and pyramids is that there's 2 heights. There's the height of the pyramid, which is this one right here, that we used when we found the volume. There's also the slant height, and the slant height's what we need when we find surface area. Surface area is the bottom, which is a circle, plus the curved part. Now the curved part is pi rs, and hopefully you've got that on your formula sheet. And of course, S is this slant height. It's this, if a fly was walking up the side of the teepee, that's the slant height compared to that's the height of the pyramid that we needed for the volume. So, well, what do we need to do? Pythagorean theorem. Bada bing, bada boom. The slant height is 10. And then I can put this into my calculator in one step again. Use your pi button. Don't put in 3.14. It's inaccurate and it's more keystrokes, right? So use your pi button. Put that into your calculator in one step, and you should get 301.6 centimeters squared. And that's a weird thing that they're the same. That's just coincidence. Don't read anything into that, okay? On to the last one. It's a square base pyramid. Square base pyramid. It comes to a point, so the volume is area of the base times the height divided by 3. And again, if you were to write S squared or LW in there instead of the area of the base, that would be fine. Area of the base here is just 5 squared. 5 times 5, length times width, is 25. The height, oh boy. The height we need for the volume, well, it's not given. Right? What was given was the slant height on us. So the height of the pyramid here we're going to have to find. Pythagorean theorem again, where the slant side is the hypotenuse. That's 4 squared. And then h squared is one of the sides. And now do you see what this other side is of this triangle? Well, that's 5. So that's half as much, right? This is 2.5. And I want to get that alone, so I'm going to subtract that from both sides. That goes into a calculator, and you get 9.75 square root, and you get about 3.1. which makes sense. It's going to be less than the slant height, right? You can see how that's a smaller length than the slant height. And then now I can find the volume. Area of the base I figured out was 25. The height of the object was 3.1 divided by 3 because it's a pyramid. And I get about 25.8 centimeters cubed. Now the surface area. Again, the idea for surface area, we don't always have a nice formula. We just want to add up the faces. So what faces do we have? We've got a square bottom. We've got a square bottom, which we just calculated as 25. And then we've got the lateral faces are all triangles, right? They're all triangles. There are 4 of them, right? 4 triangles. So I'm going to go 4 base times height divided by 2. So that's the formula for the area of a triangle. 4 base times height divided by 2, where the bases of one of the triangles is 5, and the height of one of the triangles is the slant height 4. Pass that into a calculator. 4 times 5 times 4 divided by 2, and that should be 40 centimeters squared. And so together, the total surface area is 40 plus 25, 65 centimeters squared. Okay, the homework has got a couple on your page because the textbook doesn't do a very good job preparing you for this section as far as pyramids are concerned. So there's a couple of pyramid questions. But otherwise, that's it.